Okay, so this second video on equations with fractions is actually going to focus on very much the same kind of skills as the last video, but the questions are just going to involve a few more steps or be a little bit harder in some way, a little bit odd, but the skills remain the same. So, first thing I always ask myself when I'm working with one of these, is my whole top line divided by the number, or is it just the x part? Here it's the whole of the top line. So our first move I'm going to do is times everything by 3. 2x minus 7 is left on this side because multiplying it all divided by 3 equals 18. Now we can rearrange. We've got an extra step to what we had in the previous set of questions. So I'm going to add 7 to both sides. That leaves me with 2x equals 25. Divide both sides by 2. And so x equals, now you can leave it as top-heavy fraction, or you could cancel or simplify it down to 12 and a half or 12.5. So similar kind of story on example 2 here. Again, spotting that the whole thing is divided by 8. So we can times both sides by 8. That's going to leave us with 5x plus 1 on this side. 9 times 8 is 72. We've got a plus 1. Opposite is to take away 1. So that leaves me with 5x equals 71. And then we can divide by 5. And again, a bit of a minging fraction, but that's not a problem at all. 71 over 5. And we're there. Now, things get a little bit more complicated down here, and I'm actually going to break my own rules a little bit here. You could perfectly well expand this bracket and then work from there. I would recommend spotting a little shortcut that we can do, though. If we've got a quarter at the front here, the easy way to get rid of that is to times both sides by 4. Now that's a little shortcut because timesing a quarter by 4 gives us 1, so we've just got one lot of x plus 20, or x plus 20. 9 times 4 is 36. Now we can take 20 off both sides, and so x equals 16. So that's a bit of a shortcut compared to kind of adding in lots of expanding steps that we don't need. So watch out for that one. Nice quick way to do it. This one, we've got to be quite careful because it's the 3x minus 1 that is divided by the 5. Then we're adding the 8, and that's equaling 15. Nice way to deal with this is to take the 8 off both sides first. Okay, because that 8 is not divided by the 5, we can take it off both sides. So we have 3x minus 1 over 5 equals, and we're taking that 8 away, 15 take away 8 is 7. We're then timesing both sides by 5. So we end up with 3x minus 1 equals 35. Now we've got to solve this like a normal equation. So we've sorted out all the fractiony bit, all the mess. Now we're solving like a normal equation. So we're going to add 1 to both sides. That leaves me with 3x equals 36. And now we're dividing both sides by 3. And I've only just left enough space. Make sure you leave enough space for yourself. So x equals 12. So quite a lot of work to get through that, but follow your steps, follow your processes that were built up over the last set of videos, and it should follow through nicely. This one is still a fraction, but we've got an x on the bottom this time. Now nothing changes about our approach. We're dividing all of 2x plus 5 by the x, so the opposite is to times by x on both sides. Make a nice curly x so it's different from your times sign. Divide by x times by x just leaves us with 2x plus 5. 5 times x is 5x. We've got x's on both sides, so the obvious thing to do is to take the smaller number of x's away. Let's take 2x off both sides, That leaves us with 5 equals 3x. Divide both sides by 3, and we get 5 over 3 equals x. Or if you prefer, x equals 5 over 3. Okay. So a lot of thinking to be done when you've got an x on the bottom, but the procedure remains the same. Last example, a little bit more complicated. We've got x's on both sides and a fraction. Now you'll see in the next video, we're actually going to build in where we've got fractions on both sides, but at the moment we can work with this. Same approach, we're going to times both sides by 3, because we're dividing all of the 5x minus 2 by the 3. So that's going to give us 5x minus 2 on this side, because we're doing a divide by 3 and a times by 3, which cancel each other out. Over here, we're timesing by 3. 3 times x is 3x. 3 times 6 is 18. You've got to be careful, times everything on this side by 3, and then you're there. Now, we can solve this like the unknown both sides equations we had before by taking 3x off both sides and get 2x minus 2 equals 18. Adding 2 to both sides. Now, if by this point you're bored of drawing arrows on both sides and you're feeling confident, you can stop that. I'm doing that just to make it clear. And here we're dividing by 2. And so x equals 10. So pretty, by the time you get into this point, you're solving some pretty tricky equations involving lots of different skills. We are going to do a third one on equations with fractions, which is going to cover what to do if you've got a fraction on both sides. I'll move back to doing an example in your turn there, but it builds on this idea here, and we'll see how shortly. So hopefully go away, have a quick try on these questions, and then I'll introduce that next idea with the equations, the fractions on both sides of the equation.